Hi, I'm John, and today I will take you through an exciting and forward thinking paper titled Actions Speak Louder Than Words Trillion Parameter Sequential Transducers for Generative Recommendations. Don't worry, I will break it down into something clear and very actionable. So, why this paper? Let's start with a quick reality check. Recommendation systems touch everything from what you buy to what you watch to what news you read. But traditional recommendation system models mostly do one thing, they do ranking. They take your history and score a list of items. It has worked for years, but it struggles at scale and lacks real flexibility. So, what this paper proposes is radical but powerful. Let us stop ranking and start generating instead of picking what to show you. The model actually generates your next interaction, like how GPT generates the next word in a sentence. So the key idea is the generative recommendation. Think about your interaction history. Every click, scroll, and search is like a word in a sentence. Just like in NLP, where we predict what word comes next, here we predict what the user will do next, not from a list, but as a generative sequence. So this reframe, turning recommendation system into a sequence transduction task, is the core innovation of the paper that I have selected. Okay, so now let us delve deep into the architecture, the HSTU architecture. To bring this idea to life, the authors introduced the HSTU, which is the Hierarchical Sequential Transduction Unit. This is a highly optimized transformer-based architecture that handles sequences as long as 8,192 user actions, and it scales up to a mind-blowing 1.5 trillion parameters, and still it manages to be efficient and fast. So let us take a closer look at the figure here to understand what makes HSTU different. So I put up a figure over here on the right. So this figure compares traditional DLRMs, deep learning recommendation system models, on the left with HSTU on the right. On the left, you see a classical multi-stage design, separate modules for numeric features, categorical embeddings, feature interaction layers, and top neural networks. It's powerful, but it's also complex and rigid. Now, on the right, HSTU takes a modern approach. It converts everything into sequential unified features and processes them using transformer layers. This leads to a simpler, more elegant, and flexible design. And notice how attention layers repeat throughout. You can see the attention at every stage of the diagram. HSTU uses self-attention everywhere, learning user behavior patterns across long time ranges, just like the language models do. The training strategy. HSTU doesn't just look sleek, it is trained cleverly too. So they use chunk-wise auto-regressive training, meaning they model, looks at blocks of interaction data and learns dependencies between them like chapters in a book. They introduce something called product tokenization, which reduces the complexity of the item vocabulary by grouping similar items together. This helps the model generalize better. And they also use something called gradient accumulation, which allows for training trillion parameter models on available hardware without exploding memory. So the model is first pre-trained, unsupervised, and then fine-tuned on specific user item data sets. So the data sets and deployment, when we talk about the real world deployment, this is not just something like an academic experience. HSTU is now deployed at Alibaba, powering search, feed recommendation, and ads across platforms that serve billions of users every day. And it also means it's not theoretically scalable, it's proven to work at industrial scale in real time. So when we talk about the results and performance, okay, this is the heart of the story. It is done into what makes HSTU truly stand out. They benchmark it against the best in the game. Transformer Excel, that is designed for long sequence modeling, GPT-based recommendation system models, which are the autoregressive predictors, and S4, that is built for sequence modeling with fewer parameters, and of course, traditional deep learning recommendation systems like DeepFM, etc. Let us break down what they found. So in terms of accuracy, HSTU achieved up to plus 65.8% improvement over the best GPT-style baseline in NDCG at 10, which is the gold standard for ranking relevance. That means it's much better at putting the right item at the top of the recommendation list where it matters the most. And when we talk about the inference speed on sequences of length 8.92. HSTU is 5.3x to 15.2 times faster than the competing models. And this speed is also critical in production where latency makes or breaks the user experience. And when we talk about scalability, HSTU can handle 1.5 trillion parameters. That's GPT-4 territory without slowing down. It stays stable, efficient, and accurate even at this massive scale. And when we talk about the deployment metrics, that is the real world validation. And finally, as I mentioned earlier, this is not just a lab test or an academic experience. HSTU is deployed in real time systems, serving actual users across multiple domains, not just e commerce, but also ads and search. It has been successfully deployed in Alibaba's real world search, ad and recommendation services. It handles dynamic behavior, cold start problems, and diverse platforms, diverse domains, and dynamic user behavior patterns all at once. So, in short, HSTU isn't just better, it's faster, smarter, scalable, and already live. So when we talk about a quick summary, let's sum up the core contributions. A new paradigm, reframing recommendation as a generative sequence task, not a ranking task. HSTU architecture efficiently. It handles long sequences and trillion scale data. Smart training uses chunking tokenization, memory efficient optimization. When we talk about the real world impact, it's deployed in production at massive scale and it works. So, a quick recap before I wrap up. Here are the two questions from the presentation. So, what task does this paper reframe recommendation as? As a sequential transduction task, it generates the next item, generating the next item in a user's interaction sequence. What makes HSTU and why is it so important? Why is it unique? HSTU, which is the hierarchical sequential transduction unit, it is a scalable transformer-based trillion scale model that is not only highly accurate, but also extremely fast and already deployed in the real world. Thanks so much for listening. I hope this helped you. And I've put up the reference also over here. You can see the reference, the authors, and the link to the paper over here. And finally, thank you so much for listening. I hope this helped you see the future of recommendation systems from a fresh perspective. Thank you so much.